All right, today we're going to be talking about layer 3 of the OSI model, specifically Internet Protocol version 4. In terms of where we're at in our course, we are in week 5, and so in the OSI model we're talking about the network layer, or if we were talking about the DoD TCP/IP model, we would be talking about the internetwork layer. Another topic that's related to this is TCP, and to differentiate these two topics, Internet Protocol versus TCP, Transport Control Protocol, IP is about the addressing and getting things from point A to point B using our addressing scheme, and TCP and the transport layer more broadly is about guaranteeing or not guaranteeing either of those options whether or not an IP packet gets between two different places. So this video is not going to talk in depth about that. Okay, so again, here's the OSI layers on the left and the DoD model in the second column with maybe some slightly different wording, but I want to draw your attention to the far right here where we have the TCP/IP protocol suite. So whereas these are general concepts on the left side, on the right side we have the actual technologies that fit within these different categories, and IP fits within this third layer of the OSI model. Okay, before we dive in too deep, just review for a second in your head what's the relationship among a byte, a bit, and an ASCII table like this. Okay, hopefully you paused for a second, and what you thought through was that there are 8 bits in a byte, and that any character found in this table can be created by 8 bits or any particular byte, because 8 bits can be used to create a number between 0 and 255. And how does that happen? Well, this is one example of how that works. If you consider a series of 8 ones and zeros and look at them as columns, you can set a value to each column. So you could start on the right and just start doubling them, starting at 1 and get all the way up to 128. Or you could do in the first position 2 to the 0, 2 to the 1, 2 to the second to get to the same numbers. And then if you put an actual byte underneath it, a series of 8 ones and zeros, then you could do some math with that. So you could call this ANDing, I suppose, or anyway, multiplication. 1 times 1 plus 0 times 2 plus 0 times 4 plus 0 times 8, and then sum that all up, and that would give you some particular number that's going to range between 0 and 255. So as it relates to IP addresses, we know that we have 4 numbers, and those 4 numbers have a particular range associated with them because each of those is represented by a byte. And so based on that, pause for a second and ask yourself the question, are all of these values valid for an IP address? And the answer to this question is yes, because they all fall within a good range. And I'll be more specific after the next question. How about this one? Consider this and pause for a moment. Okay, this one is not a valid number because you couldn't represent this first number with a byte with 8 bits, because there's no, within 8 ones and zeros, you can't create the number 256. You can only create something up to 255. Okay, so more on the topic of IP addresses. Historically, we have 3 different kinds of, addresses that we want to be concerned about. There are others, but for the topic of today, we're just going to talk about the first 3. So A, B, and C. These were originally intended to be for different types of organizations. And so if an IP address, such as, again, the one you would see right here, started with a number like 15, then that falls within the range of 1 to 126, and so you know that that is a Class A address. If it falls between 128 and 191, that's a B, and if it falls between 192 and 223, that is a C. One way to remember this is that if you have the 8 bits that you're looking at, and the first one starts with a 0, then it's guaranteed to be a Class A address. If the first two numbers or two bits are 10, then it's going to be a Class B address. And if the first three digits are 110, or 3 bits are that, then it's going to fall within this range. And I can prove that. I'll pull over here this spreadsheet. So this one does the math for me automatically. I wrote a little formula here that multiplies each of these, multiplies and adds the number on the bottom by the number at the top. And so if this first number is excluded from the calculation, then the highest it could be is 127. And so that almost fits within our range of 1 to 126 here. I note at the bottom here that 127 is a special number reserved for loopback, sort of like looking in a mirror on your network device. If you send out traffic to it, it just comes back. It doesn't actually go out to the network if you send traffic out to there. Okay, and if we change this from that to 1 and that to 0, then our number changes to 191 on the high end, so that fits with what we have there. If I changed all the rest to zeros, it would go to 128. And this last one, 110, 110, so this is the highest it could be, is going to be 223. So that's the relationship among the bits in your byte and the address ranges for our classes of addresses. Okay, now that's a general thing related to addresses. How about some very particular special types of addresses, those being the private address space? As local network administrators, we have the opportunity to set what are going to be the IP addresses within a particular building or room, and these are non-routable addresses. They just allow us to communicate within that particular local network. We actually have to convert our local addresses to a public address if we want to go out on the public internet and get traffic back and forth. But within a particular network that we define, we can set our devices to be any of the ranges that are listed here, an IP address in one of those ranges. And if you walk into any public building and get Wi-Fi, whether that's at a school or at work or at McDonald's, you're going to find that you have an address that fits in one of these ranges. Just at a high level, in addition to having a class associated with them, maybe a high level thought to carry away is there's actually a lot more addresses that are available in this range at the top versus this range at the bottom in total. And I'll explain more about that later. Okay, so for historical reasons, it's assumed that if you're giving out addresses in your local area network in the Class A range in a private address space, that everything that follows this first digit or number of 10 is something that can be set by you. So basically you can do 0 to 255 in this place, and this place. If you're talking about a Class B address, it's assumed that you can create a network of devices that are all shared in the same network that have two positions that represent the number of devices that are in the network. And then if you have a Class C network, it's assumed by default that whatever network you're in allows you, in this case, a number between 0 and 255 here to sign out as IP addresses. There's another thing that's going to become useful in a minute here. So there's the number of, there are bits associated with each of these positions. So there's 8 bits here, 8 bits here, and 8 bits here. So there are 24 bits that are assignable. If you take 24 to the power of 2, that's going to become very important to you. If you take, in this case, 16 to the power of 2, that's going to be useful. If you take 8 bits here to the power of 2, that's going to be useful as well. What it's going to tell you is the number of addresses that are possible, the combinations associated with that particular range. All right, let me go and talk about another topic now. Again, trying to get our heads around what is an IP address actually. So on the left-hand side here, we have a building. And buildings are, if we want to, well, let me tell a quick little story here. Once I did an internship with a company in which I was assigned, well, I could be randomly assigned to a cubicle on any given day. So let's just say that I was assigned to a 26th floor cubicle, and it was cubicle number 73. Now, 26,073 is a unique identifier for the place that I was in, but it doesn't uniquely identify me. It's just where I was on any particular day. IP addresses kind of work very similarly in that there are networks associated with where you're at. There's a particular location within that network that can identify you, and you might get a different place assigned to you or a different IP address on any given day. So if I come over here to the right-hand side here, you see what are in these gray ovals. These are 3 different networks. These networks are separated by routers, and let's start with the first one. The name of this network is 172.18.0.0, and what this means is that this is a unique network, and underneath those, in this particular case, we can add numbers where those zeros are. It's not always going to be the case that it's going to be a 0 that defines your network, but in this case, in these 3 cases, that is. And within this particular network, we can add numbers here, or insert numbers between 0 and 255, and those could represent devices within that network. So we've got 1, 2, 3 different hosts here, or computers that are on the network, as well as one of the interfaces on the router. So there are 4 different IP addresses associated with this network that have been given out. Here we have another network, and there are 3 IP addresses that are assigned out, 2 to the routers and 1 to the machine. And then lastly, over here, we have another address, another network, and there are 1, 2, 3, 4 IP addresses associated with that. And so just like a floor gives you the general area that the particular thing is going to be found in, the network gives you the general location within which a particular IP address is going to be found.